I'd like to invite Shiv Iyer, founder and CEO of MinervaDB, and also a well-known MySQL community expert, to walk us through with detailed guidelines and scripts what he calls the golden five for effective MySQL troubleshooting. Hi Shiv, welcome to the webinar and thank you for joining us today.
Hey
Could you,
Shreya,
yeah,
thank you
please go
so
ahead.
much for the invite. So first of all, very happy New Year, everyone. Thank you so much, everyone at Microsoft Azure team and Shreya, Parikshit, and rest of the team, right, for inviting me for this talk, right? And so when we started the conversation first, and like I'll just do a quick intro, right? When we started this conversation with Shreya and Parikshit, so like I gave three topics. One is about troubleshooting MySQL, the top five golden five. So I call it top five golden five. The reason because, right, often like I've been in the business of MySQL open source database systems for over 2 decades now, right? So when I start conversation with a CTO office to a database engineer, they ask like, tell me what are 5 things you can do, right? Just 5 things, right? How you can do that. So the top five, golden five, evolved from there, right? A quick background of mine, and like I was the first MySQL engineer joined from Southeast Asia and MySQL AD team. First full-time consultative data SRE for Twitter. I worked even with Percona Palomino DB. I currently the founder of MinervaDB and just Data, right? I've been like across open source database systems infrastructure on MySQL, PostgreSQL, MariaDB, and ClickHouse, right? Across both OLTP and OLAP database infrastructure, right? So that's my professional background. So I've worked with several enterprises, several internet properties, very large internet properties in my last 2 decades of MySQL engineer, data engineer roles, right? Across the functions. When I say across the functions, I've been a database architect, I've been an engineer, I've been a data SRE, I've been a data ops guy, on call, right? So predominantly the focus has been always about performance and scale, right? More on troubleshooting, right? Work on from the consumer-facing internet companies to the fintechs, to the ad techs, OEMs, some of the largest payment integrators globally, which includes SWIFT and which is for the global financial intermediary service handling. Also UPI for India, right? So this is my background on professional interest, and so I talk with the agenda of the talk today. Like I said, right, the whole objective. Shreya, you can go to the agenda of today's talk. Thank you. So the whole agenda is that what are those top 5 things which I remember when I go for talking to a customer, right? How does this all begins? So I'm not reading through the deck. I mean, I'll give the talk over the deck. My deck will be definitely available for you to download. Also, the scripts which I use for troubleshooting, at least for the preliminary performance audit. Because when you talk about troubleshooting, this is a job of a detailed forensics diagnostics activity, right? Like you need to collect the data, like the evidence is important to decide that what are you going to do with your database, right? So how do we start? We start right from the infrastructure, right? First, before defining the goal of your database infrastructure, we need to know that what's the capability, what's the throughput of this infrastructure we are building, right? The capacity planning sizing is something which comes as one of the most important tasks, which every MySQL infrastructure I work very closely with. This is to make sure that we are setting the expectations clear, right? If you have a larger database, of course, we need to build the infrastructure for that, right? There is no magic system variable which you can set that, hey, move fast, right? That's not there. Also, building the Linux for that, right? The impact on the performance on tuning the Linux is sometimes even beyond what you have, kept as your golden rule. Like for example, I've seen that transparent huge pages. Database don't need a transparent huge pages, right? So disabling that makes a immediate instant gratification kind of a performance, right? Swappiness. So I'm getting into a stage that from the hardware to the infrastructure to the Linux, then to tuning the server, right? The goal here is that one, identify your infrastructure for your load. Two is build or tune your Linux for that. The third one is that how are you provisioning the resources to your MySQL server, right? And then understand that what is going to be the application. Get into understanding about which are the SQL constructs, the data access path, which are going to be longer and deeper and intense, and which are the large data objects and how the index operations work like, right? Next talk. So what this talk isn't about, right? I'm not talking about a hands-on performance engineering lab. I'm not even talking about what are the application development best practices, not a DBA session, and also isn't any recommendation from MinervaDB on MySQL troubleshooting. So like I often say that the talks are about the experience, right? The experience experts, right? As what we talk today is not what we are going to use as an experience to troubleshoot, right? So this is purely the knowledge one. Like you want to use the scripts, of course you can use it, but be aware that what the scripts are run, right? So the most important activity I've seen professionally is that when I talk to any MySQL property owner, right, the performance, the speed, right? When you accelerate your database, you are accelerating your business, right? So my audience, though it begins with the CTO office, later it moves to the business and the CEO office and other stakeholders. Reason because when you make your database faster, you're making your application faster, you are making customers more successful, keep them more engaged. We all play games and we like faster gaming infrastructure. We are like on a consumer tech front, like we like everything move faster, right? Like to shop on a faster site, go for a travel booking on a faster site. So the speed is everything, right? So if speed is just a limited scope of user experience, it is where it begins with, but the speed, the accelerated systems accelerates the growth of your business, right? So the golden five, like I said, right, begins with building the infrastructure. The next is like know your Linux build, right? If you have a scope to make your Linux optimized for your MySQL, don't miss that. And the answer is yes, we can tune the Linux for MySQL. Identify what is your MySQL growth, right? How big your database can be. And this cannot be a one-time job, right? When we start, like definitely we'll not have much data and there will be no compliance. Like I often say in my talks, none of our customers, none of the engagements I've did, right? They never had any issues till the data get in, right? Till there is no data, like till there is no data, everything is good. When the data gets in, that's when people complain about, like I have a slower MySQL server, right? And this leads to everything, right from the data architecture, design, build, the SQL construct, how is the SQL data distribution, access distribution looks like, the intensity of the disk IO happening, right? The next one, right? This is my favorite diagram. Shreya, we can move to the next diagram. Okay. This is one of my favorite diagrams, right? I tell you why. This pretty much captures about what is the roadmap of a MySQL performance audit look like, right? It originates from a suboptimal MySQL infrastructure to the expensive queries, right? Often oversized, undersized, both oversized and undersized database objects, the schema objects, will eventually have expensive query operations. And it's a natural tendency that when a database is not performing fast, have many indexes. There is no restriction, right? Like nobody says that, like there is no golden rule in MySQL world that, limit the index, right? So every engineer, every developer find an index for their query is a right decision. When that is allowed and approved, right? You end up in seeing many indexes happening, right? And everything leads to the expensive disk ops, right? It looks the last box in my diagram is the expensive disk IO operations, and that's where the core epicenter of the problem, right? Now, when you access the disk quite frequently, um, that results in high latency query operations, right? When your latency of the query goes higher, then it's a tendency that it's about changing the wheel of a running car, right? Some point of time you realize that, hey, you know something, it's a time for us to horizontally scale MySQL, right? So here we are actually treating the symptom, not the problem, right? Like, what are we trying to do? We are adding more MySQL, right? The problem remains. We add more MySQL. We split the data ops read, the reads across many infrastructure. And eventually, right, these all look like interim solutions, right? You will have this get solved for some time, then a new problem will come up, right? About how is your partition model looks like, right? So when you build a schematic representation of your database architecture, right, where do you start it, right? Next slide. Okay, so when you get to infrastructure, this is something which I've spent many days on the debates, right? Faster CPUs, several CPUs, right? It's a very interesting one. It depends, right? I'm not saying that use faster CPUs for everything, or like several CPUs solve many problems, right? In my experience, especially when I'm working with the consumer-facing internet companies' database infrastructure, for me, the faster CPUs really works optimal when you have like when you're looking at the performance of the independent queries, individual queries are crucial, right? And also, like if you are looking at improving the disk operations performance. If you are looking at like a faster index operations, faster online schema change operations, those scenarios works really fast. The case will be slightly different if you are looking at parallel processing capabilities. If you are ever using MySQL for OLAP, right? People use MySQL for OLAP, right? There are cases where people use MySQL for OLAP, where they use like, hey, those are the read instances, right? For them, like that, in such scenarios, right? Several CPUs work. Building MySQL for a parallel query objects model, right? That really works good, right? So there is no right one single answer, right? Again, it depends on how your database look like. If you are looking at a very fast transaction processing system, right? Every single query performance is very important for you. Order processing, right? For most of my e-commerce customers, my ad tech technology customers, for them, it's about the transaction processing model, right? As fast as possible, create orders, right? Or gaming companies. I work with many gaming companies. I worked in the past with many gaming companies or fintech. For them, it's all about the faster isolated transaction completion, right? That is the faster CPU works. When I'm working with the SaaS companies, right, they have a lot of sort search intensive query operations. They want to look at like how the data reporting infrastructure represents to some of the functions. For them, it works with several CPUs ecosystem, right? So, like I said, like as a database engineer, right, I start my, like my first piece of work in every engagement is like understanding the data access path. So when I understand the data access path, right, it gives me the clarity about what is the direction I'm going to take. Shreya, next slide. All right. So I feel like MySQL is memory intensive, right? It works great on a larger memory infrastructure, right? It's its answer is also quite direct. Originally, or even today, MySQL is a database for many of the internet properties, right? Which could be in the form of a simple WordPress to many internet applications where you read more and more, and reading from the memory from the RAM is always faster than to the disk. So the whole goal is being like how big your database can be. Can we get as much as your database to the available RAM? Invest on a higher performance RAM, right? And can we identify that and cache your data objects, right? That's it. In about how do we work on the sizing of your InnoDB buffer pool size, right? It's a general rule of thumb, but then make it 70% of your database size, right? Yes and no, right? I don't believe in professionally. I don't believe in the golden thumb rules, right? I believe in the golden rule of matrices, but I don't believe in the thumb rules. Actually, why, right? Shreya, you can go to a diagram of infrastructure capacity planning sizing. The next one, okay. So let me tell you this. Like one of my customers in the past, right? They wanted to build a very large MySQL database, and the 70%, 80% of your RAM is for InnoDB buffer pool, right? They had a database of as big as like 250, 300 GB of database, right? And they had like 512 GB RAM, right? They just directly kept 70-80% of it, right? Of the RAM. It was the database was performing pretty well, right? And this is the right thing to do. Like the entire data got into the RAM, everything. But then the point was that they never planned for how big the database can become, right? So typically what I do is like when the database gets bigger and bigger, I get I build MySQL horizontally. The reason because if I find again, this is about the classification I do when I'm building a very ultra low latency database infrastructure, right? I'll break that into three clusters, primary clusters, where the latency is unacceptable, right? It's about say about a gaming one, right? When I'm playing the game, I need to pick up article and I start playing. So all these the ad conversion, everything should happen very quick, as fast as possible, right? And so when you don't build a capacity of how big your database can be, and when your database performance is the key of the business, then you got to build the database infrastructure so that your primary database will be on your RAM as much as possible. Then the older ones, which are like not frequently accessed, they'll be replicated to a replica instance. And the third one is the failover. So my database infrastructure always look as three. I'm not saying three node, the three layer of clusters, primary clusters with the hot objects where the data is accessed quite frequently, and that will be cached in the RAM. The secondary one, 30 to 40% of that will be on the RAM. The remaining will be on the disk. The failover will be a much lower instance. The whole goal is that not just setting once a large InnoDB buffer pool size and just forgetting it is not scalable, at least if you're building ultra low latency infrastructure. So I would say that don't go by the thumb rule. Build the infrastructure for the performance, right? So what I look forward to, Shreya, next slide, about, okay, so what I look forward always is that how I can get as much of data can be from the RAM, right? Typically, I compare the read request to the actual reads from the disk, right? A higher ratio of read requests to the disk really indicates that we have a well-performing buffer pool, right? That's where your data is there in memory, like I was saying, right? Identifying where your data lies in is very important, right? And always, invest on the primary cluster of your database infrastructure on a higher performant RAM. I move to the scripts, 2 slides after that. My scripts for monitoring the memory consumption. So these are the two scripts which I use. So all my scripts are SQL scripts, right? The SQL ones. Um, Very minimally invasive, right? There is no agents, nothing. This helps you to understand how your available RAM is consumed by MySQL, right? And the matrices which I use, like what is the InnoDB buffer pool usage? Like I said to you, like I don't believe in the thumb rule. When I get the evidence, based on the evidence, I size my database, right? The next one, like I said, like faster SSDs for a web scale really works fast, considering the IOPS as well for the time to recover. This is very important. Like basically, when people ask me like why SSDs, so is it only for performance? I said no, not just for performance. There are three major reasons. One is about the the faster business completion. That means like the high-speed data access. The second one is like the IO efficiency, right? You're not investing more on the cost of IO. The third one is about the reliability and durability. It's about the time to restore in case of an outage, right? So how we can be as database systems goes down, but then when it goes down, how do we come back as fast as possible? The next slide is about how do I build my Linux server, right? Like I said, right, Linux has a natural tendency to swap out everything, not just MySQL. It can be PostgreSQL, it could be a ClickHouse, it could be a MongoDB, anything. Linux naturally swap out everything, anything and everything, right? So how do you keep the swappiness as low as possible? Don't make it zero. I've seen people making it zero. The greed is no good, right? Even in database systems world. Making it zero means your server believes that you have unlimited, like memories available, right? So that will just bring down your database permanently. Maybe it causes severe damage, very expensive for recovery, right? Restoration. Max open files again. When you're looking at a very high concurrency database infrastructure, I tune the max open files. This will reduce the I/O latency. The network infrastructure, I work on the timeout TCP timeout parameters and the recycle one to optimize the TCP/IP performance. But this is something which you have to be very careful. This works really like magic on a very high traffic internet property, but again, too high is not too good, right? Too much is not too good here, right? The CPU usage, how do you use it? Setting up the nice levels to prioritize the MySQL processes, right? It's about, again, like unless you understand there is going to be a CPU intense infrastructure, I would say sometimes don't even touch it unless you have expert guidance on that. Next slide. So most important, like monitor and tune. Don't tune without monitoring, right? The CPU affinity, right? So you said it very carefully. So if you are looking at building our database infrastructure is going to use MySQL infrastructure is going to use CPU efficiently. Your application is designed for a partition, parallel sequels running on it, then you can work out on affinity, right? On an 8 core, it's like I use a task set of 4 cores. Like this is very pessimistic, very conservative value. Can be aggressive, but should be very careful, right? So the thread operations, like everything in MySQL is MySQL makes a relationship, the connectivity to the application. Your SQL works with the database through threads, right? You can go to the diagram, which is about MySQL tuning and configuration, right? When you're troubleshooting a MySQL performance, like from a performance engineering background, three most important matrices need to look at is like how expensive are your application queries? How are you tuning them, right? Do you have the list of like top 5 most expensive queries by response time? Of that, how many of them are falling on the bucket of full table scans, which causes a very high disk I/O operations, complex large join queries, and so that means that either your MySQL is serving some request or it's waiting for resources. These are the only two possible scenarios, right? When you say that I have a performance bottleneck in my MySQL infrastructure, that means that either your MySQL is the request, the query request during the peak load that can be very high, or the MySQL processes are waiting for the resources for that. The third important aspect is about the indexing, but that is a combination of both, like expensive indexing, bad indexing. There's nothing bad. There's like expensive, unused, or used, right? Expensive indexing and unused are very tricky to troubleshoot. The reason because that you will have the index, your query still works bad, right? So you need to isolate and identify where is the epicenter. The next metrics. So how do I troubleshoot the MySQL thread contention? I look for the log time. Like I said, right? How much DB is the default storage engine is waiting for the MySQL resources, right? What is the thread volume, right? How many threads are running currently? How the available RAM is used by InnoDB buffer pool, if there are any deadlocks, and what is the checkpoint frequency and the transaction history. So the whole goal of mine is about how the resource adoption happening, how is the query distribution happening, how is the index efficiency, and are we locked for the resources. The next diagram is about how the thread operations in MySQL are distributed. Like I said, right, everything which happens both internally and externally on MySQL world is through threads, right? When I say internally, it's about the transaction log completion, the resource access controlled by the MySQL lock mechanism. The query operations from via MySQL buffer pool, right? Or the log transaction completion, right? Everything is about the thread efficiency handling. So the next diagram, which talks about how the threads operates within MySQL, right? Like this is why I said the threads are busy processing the request, or threads are waiting for the resources to process, right? These are the only two states. So identify as early as possible. The next diagram which talks about which is about on an inverted tree structure of how the MySQL thread operations looks like. Like I said, right, busy on waiting for the resources, busy serving on the transaction completion, and about the query efficiency. Everything is linked to the thread ops, right? So these are my collection of scripts for the thread ops. I got to accelerate. I got only 5 minutes. So the most important thing is like I often say about how large objects impact on MySQL performance, right? When I have an emergency MySQL performance troubleshooting engagement, where I have the time is very limited, like now, right? I start with identifying which are those top 5 tables, and all my queries will be on those tables, right? Now what next? What's the fastest way to tune a MySQL or any point of time? It's like identify the larger tables, partition them, right? You brought down the crisis under control by 50%, right? Smaller data sets, that's a quick magic, right? But then should be careful, right? On a very large data infrastructure, that also looks very tricky and very cautious things to do, right? When I work on, so the next one. So when I work on very large data sets, I'll be very careful about the indexes. Like I said, many indexes and limited indexes, both are equally a pain to solve for us. The redundant indexes are often end up in increased disk I/O, right? And under-indexed causes, again, the query latency. So I have scripts to identify. So this works like a checklist for me. These scripts operate in a form of a checklist. I'm happy to share more. If you have, I'm very active in the social media, right? You can write to me, my email, everything, right? So identifying the hot I/O objects. That's what I said. Like if you know which are those very expensive schema objects in your database infrastructure, isolate them. If you concentrate, if you taper on troubleshooting the performance of those, you're almost on the right direction on troubleshooting. All right, so I move to the 4 critical don'ts for a MySQL production infrastructure. I don't over-index. I'll be very careful. Next. Shreya, next. The next one. All right, so I do what I don't do, I don't over-index. I'll be very careful about. I'm very conservative about indexing. Uh, please, never, ever uh, speculate. Take a risk on your backups, right? Don't overlook the query optimization, right? Means that you have to invest on the query performance, but then tuning the same query many times can result further complexities, right? Because you are skewing the optimizer to build execution plan every time you do that. I would rather say that if you can do it right once and accept the fact that MySQL is not built to handle very large data sets, right? Think about horizontally growing it, archive the data, it works really good. Security policies, last but not the least, never compromise on this actually. What is the whole overall scope of the performance audit of mine is like understand what is the current state of the infrastructure, right? That's very important. How big your database is. Like I said, top tables. Work on the thread operations which are very expensive, like identify the expensive SQLs. Um, disk IO is always, every performance bottleneck will have a disk IO, epicenter there, right? Look at the indexing, have a clear maintenance operations runbook, right? MySQL performance is never a one-time job. You'll be doing it always. As you do more with your database get bigger and bigger, it get more complex. Um, Invest on a good MySQL monitoring infrastructure. That's always worth, right? Open source, free, SaaS, anything. But have your MySQL monitoring infrastructure you believe in, right? You can count on. That's very important. With that, fine. I'm closing my talk. Thank you so much, guys. Thanks for giving me the extra time. Like I said, I'm always happy to respond to the queries. Always happy to connect. Look forward to talking. Thank you.
Thanks so much, Shiv. I know, this has been a super insightful talk, and I'm sure our viewers found these 5 steps extremely useful and are wishing that we had more time for you. Firstly, folks, you can reuse Shiv's script as per as your troubleshooting needs. I will share the links here. Yeah, the link to the GitHub repository with all his scripts will be here, and we'll try to upload his slides into this repository as well. And we plan to have Shiv delve deeper into each of these steps a little more in detail in future sessions with videos and demos and more. So stay tuned, folks. But for now, I know there was one question on the chat from Shubham for Shiv. We'd love to take it offline, or like Shiv shared just a minute earlier, you can contact him on his email ID as well. But thanks again, Shiv, for taking the time out to be with us and sharing your expertise and your experience. Thank you.
Thank you. Thank you so much, guys. Look forward to talking. Cheers. Bye.